Hello class 12th, welcome to Continuity and Differentiability lecture number 3. So what's up guys, how are you all doing? Today we are back again with our limitless series where we will be learning about so many different new things. Okay, so welcome to all of you and I hope that you guys are doing awesome and great. Hello, hi guys. Oh, sorry, today's topic is not parametric form, my mistake. Today's topic is exponential and logarithmic derivatives of these functions. So, yeah, welcome everybody. Today, hi Deepthi, hi, how are you? I'm absolutely fine and doing amazing. I hope you are doing amazing too. So guys, in this chapter we have already learned till now what is continuity and differentiability, using chain rule for solving some composite functions, derivatives of inverse trigonometric functions and derivatives of implicit function. Now, in today's class, we will be learning about what are exponential and logarithmic functions, how to find out derivatives of logarithmic functions, and how to use log for doing differentiation. That is a very interesting topic which we will do today. Okay, and after this, two more topics will be left: parametric form and second order derivatives, which we will do in lecture number 4. All right. Now, till now we have completed already the 8 topics. Now, today we are going to cover exponential and logarithmic functions, differentiation of exponential and logarithmic functions, and logarithmic differentiations. Okay. Yes, Deepthi. Yes. I hope you are doing good. All right. So, yeah, now in class 11, you guys have already learned about exponential functions. You know what are log functions, but I'm pretty sure you might have forgotten about it till now, right? Yes or no? Yes or no? How many of you remember what was exponential and logarithmic function? Jesse Matthew, yes. It is for CBSE students and Kerala board students, both. Okay, so this is Vedantu Malayalam channel and we cater to both CBSE board and Kerala board because the syllabus is same for both of them. Okay, and of course we prepare you for all the Kerala competitive exams as well. So definitely you can subscribe, join this channel and continue the fun learning experience with us. Okay. Awesome. So, are you guys excited to learn about exponential and logarithmic functions? Yes or no? Let me know in the chat box. How are you feeling right now? Nervous, confused, that you don't even remember what it was? Or you are excited to learn about it? Okay, that's going to be something new and exciting for us. Let me know quickly. All right. So, let's begin. What do we understand by these two functions and what is the relation between them? Now, any function that is basically growing at a very sudden rate, okay, or decreasing at a very sudden rate, okay, that is called as exponential growth. So, when a function is of the form a base to the power of the variable, like the basically independent variable which is continuously changing. Such functions are called as exponential functions. So suppose we have an exponential function b to the power x is equal to a. Now, what happens when we convert it into logarithmic functions? It get converted to the form of log base b a is equal to x. So this is how we find out the value of x. Okay, so this is the relationship between exponential function and logarithmic functions, which we already know. That's not new for us. Okay, what is new for us is how to find out derivatives of these functions. Now, how many of you remember algebraic expression? Tell me quickly. How many of you remember algebraic expressions? Yes. Algebraic expressions? For example, 2 to the power 3 into 2 to the power 2. What happens? Yes, Deepti knows it. It becomes 2 to the power 3 plus 2. Remember? Let us now basically apply that laws here. So in algebra, we have learned same base, different powers. When multiplied, what happens? The power is added. So x to the power m plus n. Very good. When it is division, what happens? X to the power m minus n. We do subtraction of the powers. When it is power of power, we multiply the powers. M into n is equal to x to the power mn. When the power is 0, any number to the power 0 is what? 1 always. And any number to the power minus 1 is what? Reciprocal of that number. Very good, Deepti. So these are the laws of exponents. Now, shall we apply the same laws in log as well? Well, what will be log A into B? Any guesses? So just like algebraic expression, we have log of A plus log of B. When it is multiplied, we basically can write it in the form of log A plus log B. When it is division, it will become log A minus log B. Okay. When it is a variable to the power of another variable, log A to the power n. Now this is the most important rule. Okay. When there is exponent, that exponent comes in front and we simply multiply it with log base A. So whatever is the power, it will come in front when you are applying log. Remember this, it is very important. Now any guesses? Can you guess what will be log 1? Just guess. Just guess using laws of exponents. Can you guess what should be log of 1? Log of 1. Yes, very good. It will be 0. So, log of 1 is always 0 and log of x to the power minus 1 will be minus log x. Why? Because again, the power will come in front. So, it will be minus log x. Clear to all of you that these are the laws of logs which you should remember for solving any type of question in this chapter. Alright. Now let's learn about differentiation of exponential and logarithmic functions. So their differentiation has fixed formula which you should remember. Okay. The formula is differentiation of e to the power x is e to the power x. Nothing else. Differentiation of log x is 1 by x. Nothing else. Okay. Differentiation of a to the power x. A to the power x means 2 to the power x or 3 to the power sine x. Anything of this form. Differentiation of a to the power x is basically a to the power x multiplied with log a. Okay. A to the power x multiplied with log a. Differentiation of x to the power x. Remember, it is x to the power x into 1 plus log base e x. Log base a x differentiation is 1 upon x into log a. 1 upon x log a. Please remember this. Okay. These are the only formulas that you have to use in this entire chapter for using differentiation of exponential and logarithmic functions. Okay. Let's apply them in a question and see whether you are able to solve it or not. What is the differentiation of e to the power minus x? So dy by dx is differentiation of e to the power minus x. What is differentiation of e to the power x? It is e to the power x. But since it is minus x, differentiation of minus x is minus 1. So we will multiply it with minus 1. So it will be minus e to the power minus x. Okay. Similarly, what is differentiation of sine log x? We will apply chain rule. So dy by dx is differentiation of sin x multiplied by differentiation of log x, because that is chain rule, na? First you differentiate sine, then you differentiate log. So what is differentiation of sin x? Cos x. So it will be cos log x, and log x differentiation is 1 upon x. So this is your answer. Cos log x upon x. That is differentiation of sine log x. So everybody understood how you will apply differentiation of exponential and logarithmic functions. Okay. Now comes the most important topic, that is logarithmic differentiation. Now this topic is always asked in your board exam or in your competitive exam, because this is very useful differentiation. How it is useful? See, whenever you have a function to the power of another function, for example, suppose you have x to the power of x, or you have sin x to the power of log x, or you have log x to the power of, let's say, cos x. So any type of function where one function is power of another function, for doing differentiation of such function, we use logarithmic differentiation. And what is logarithmic differentiation? Let's take an example. Suppose I am doing here log x to the power of x square, let's say. So what happens here is, I will assume it to be y, and then I will apply log on both the sides. So it will become log of log x to the power x square is equal to log of y. Now we know that log of x to the power n is n log x. The power comes in front. So here also the power will come in front, and we will have log of log x is equal to log y. Now we will differentiate it. So this is product rule and this is log y differentiation. Easy. So whenever you have a function to the power of another function, we will apply log on both the sides for doing the differentiation. Okay. This is logarithmic differentiation. Second thing, whenever you have differentiation of log of a function, for example, differentiation of log of sin x, you can directly write as sin x differentiation cos x upon sin x. So you will get cot x as your answer directly. How is that coming? How is that coming as the answer? Just apply chain rule here. We know chain rule. Differentiation of log x is 1 upon x. Then differentiation of sin x. So this becomes cos x upon sin x. See, we got the same thing here. So whenever you have differentiation of log of a function, the function can be anything. You can directly write it as f dash x upon f of x. Okay, that is the second formula for logarithmic differentiation. Now, some more properties of log functions which we are going to use further. Please note it down. Log of a into b is log a plus log b. Log of a divided by b is log a minus log b. Log of a to the power b is b log a. And log base b a can be written as log a upon log b. All these formulas and properties are important for solving the coming up questions. Okay. Now, let me show you how do we apply log for doing differentiation. Okay. My question is, y is x to the power x. Then what is dy by dx? Apply log on both sides. When you apply log on both sides, what do you get? Log y is log x to the power x, right? Now we know that log x to the power n is n log x. So this will become log y. This will become log of y is x into log of x, right? Hi Amjit. Now we do differentiation, d by dx of this, d by dx of this. So we will do differentiation on both the sides. What is log y differentiation? Log y differentiation is 1 by y because log x differentiation is 1 by x. But since y cannot be differentiated with respect to x, so we will multiply it with dy by dx. It will be there. Next, here we will apply product rule, differentiation of x into log x plus x into differentiation of log x. Product rule, remember everybody? So we will get 1 upon y dy by dx is equal to dx cancel. So we get log x plus x into log x differentiation, x into 1 by x. X cancel. So we get dy by dx is equal to y into 1 plus log x. Now what is y? Just put it here. Dy by dx is x to the power x into 1 plus log x, because y is x to the power x. And this is my answer. See, I have told you the formula also na. Differentiation of x to the power x is x to the power x into 1 plus log x. This is the derivation of that formula. Understood how we will apply log? If not, let's do one more question. X to the power of sin x. What we will do? Let y is equal to x to the power of sin x. So log y will be log x to the power sin x. Now we do differentiation. Differentiation of log y, differentiation of this side. So first of all, this will become sin x into log x, right? Because the power will come in front and after that we will differentiate it. So log y differentiation 1 by y dy by dx. Product rule, first function, second function. Differentiation of sin x into log x plus differentiation of log x into sin x. So we get 1 by y dy by dx is equal to, differentiation of sin x is cos x log x plus differentiation of log x is 1 by x into sin x. Now we simply multiply dy by dx is equal to, y will go to this side, so x to the power sin x into cos x log x plus sin x upon x. This is my answer. Okay. So what we are doing here, step number 1, we apply log on both the sides. Step number 2, we differentiate both the sides. We apply product rule if there is a product of two functions, and when we differentiate it like that. Alright guys, so everybody understood how we do logarithmic differentiation. Now, quickly solve this homework question and tell me the answer in comment section. I will see who answers it correctly and fastly. Alright, so just answer A, B, C, D, whichever you feel is the right answer. Okay, now moving on to practice time. So we have learnt about exponential functions, logarithmic functions, their derivatives and logarithmic differentiation. Now let's practice question because without question you will not understand anything. Hai na? Chalo. Question number 1. Differentiate the function x to the power x minus 2 to the power sin x. It will be differentiation of x to the power x minus differentiation of 2 to the power sine x. Now what is differentiation of x to the power x? Just now we have derived it and we know the formula also. Tell me. What is differentiation of x to the power x? Just now I have told the formula. It is x to the power x into 1 plus log x. Direct formula. X to the power x differentiation is x to the power x into 1 plus log x. Minus. Now, 2 to the power sine x is in the form of a to the power x. Now, what is differentiation of a to the power x? It is a to the power x log a. So, here it will be 2 to the power sine x log 2 a to the power x log a. That is my answer, right? So, here let me also show you guys what we are doing. Yeah. This is a to the power x into log a. This is what we are doing. Understood, everybody? But we will also multiply it with differentiation of sin x because chain rule says that till the last function you have to differentiate. Okay. So now my answer will be x to the power x into 1 plus log of x minus 2 to the power sine x log 2 into cos x. Because, where are we? Yeah. Differentiation of sine x is cos x. So this will be my final answer. If you want, you can like simplify it further also. If you want to leave it like this, you can leave it like this also. So x to the power x 1 plus log x minus 2 to the power sine x log 2 cos x. This will be your answer. Okay. Next question. Differentiate y is equal to log x to the power cos x. Simply apply log on both sides. When you apply log on both sides, log y is log of log x to the power cos x. Now, whenever power is having, there is a power, it will come in front. So, it will become log y is equal to cos x into log of log x. Now we will differentiate it. Differentiation of log y is equal to differentiation of cos x into log of log x plus differentiation of log x into cos x, because it is product rule, first function into second function. We will apply product rule. What is differentiation of log y? Log y is 1 upon y dy by dx. Next, cos x differentiation is minus sin x log of into log of log x plus, what is differentiation of log x? Differentiation of log x is, log x differentiation is 1 upon x. So my variable here is log x, so 1 upon log x into log x differentiation. Log x differentiation is 1 upon x. So I will get 1 upon x log x into cos x. Cos x will remain as it is. So finally, dy by dx is equal to, y will come to this side, log x to the power of cos x multiplied with minus sin x log of log x plus cos x upon x log x. That is my complete answer. Oh my God. It looks very, very lengthy. See, this question is very easy. It's just that you should know how to step by step differentiate using chain rule, using product rule, using question rule. You should know how to differentiate these type of functions. If you know that, then it is very easy for you, right? Okay, next question. Differentiate this function with respect to x. Let's differentiate it. Now here there are three functions. First function is sine square function. Second function is sine function. Third function is root x function. So it will be basically differentiation of sine square root x into differentiation of sine root x into differentiation of root x. Chain rule, okay. What is sine square differentiation? 2 sine x. So it will be 2 sine root x. So x square differentiation is 2x, like that. Into sine root x differentiation, cos root x. Into root x differentiation, 1 upon 2 root x. Now you get, see, 2 sine A cos A. Formula is sine 2A. So it will become sine 2A upon 2 root x. This is my answer. Very, very simple answer here. Because this into this is sine 2x. Sine 2 root x. And divided by 2 root x. That's your answer. Alright. Basically, I have used the formula 2 sine A cos A is equal to sine 2A. This formula was used there. Okay. Now, a very, very interesting question on your way. If x into y is e to the power x minus y, show that dy by dx is equal to this. Is it looking scary to you guys? That, oh my god, what is this? Is it looking like that? Okay, let's see. Now, don't worry. What we will do? We will simply apply log. As always, apply log on both sides. So, once we apply log on both sides, we get log of x into y is equal to log of e to the power x minus y. So, this will become log x plus log y. Log a into b is log a plus log b is equal to log base e, e. Power will come in front, x minus y into log base e, e. Now, remember, log base e, e is equal to 1. So, this will be nullified. So, we have log x plus log y is equal to x minus y. Now, we will differentiate it. Differentiation of log x, differentiation of log y is equal to differentiation of x minus differentiation of y. So, we get 1 upon x plus 1 upon y dy by dx. We get 1 minus dy by dx. Do we have more space? Yeah. Now, we will bring dy by dx on one side and remaining on the other side. So, we get basically 1 by y dy by dx plus 1 dy by dx is equal to 1 minus 1 upon x. So, we get 1 upon y plus 1 common dy by dx is equal to x minus 1 upon x. Again, we will take the LCM. What we will get? 1 plus y upon y into dy by dx is equal to x minus 1 upon x. Now, send it to the right hand side. So, dy by dx is equal to y into x minus 1, x into y plus 1, and hence proved. This is what we had to prove here, right? This is what we had to prove. That dy by dx is y by x, x minus 1, y plus 1. We got it. See, it easy, right? So, what we did, we applied log Then we differentiated log and we got the answer very, very simply. Alright. So yeah guys, that's all for the day. I hope that you will now be able to solve logarithmic differentiation questions. Let's summarize. What did we learn today? So we have basically learned about exponential and logarithmic functions, how to find out their derivatives, and lastly, logarithmic differentiation. Now, this formula mind map will help you understand logarithmic differentiation in future also if you forget it. Okay, so yeah, this is what you should follow when you want to do revision. Now, in the lecture number 4, that is the last lecture of this chapter, we are going to cover derivatives of functions in parametric form and second order derivatives. So, see you all in the next lecture. Also, if you want to get the notes of this chapter and today's lecture, don't forget to join our Telegram channel. The notes are provided there every day for every lecture. You get all the notifications, all the assignment links, and every information is provided there after the class. So do join the Telegram channel. It's very simple. Just scan this code and you will be there. Okay. And yeah, if you enjoyed today's video, don't forget to hit the like button and subscribe to the channel if you are new here. Okay, because if you won't subscribe, how will you get to know about all lectures coming up for +1 and +2 competitive exam preparation, JEE, NEET, KEAM, everything has been planned for you. So do subscribe, and that's all for the day. Thank you for watching. See you all in lecture number 4. It will be on Monday. So keep waiting till then. Thank you guys. See you tomorrow. Bye-bye.